In this tutorial, I will show you how to place a part wherever you want in three-dimensional space, and I will show you with the example of linear bearings. We will change linear bearings from SBR to HDH bearing, and we will give some parameters, and we'll do that everything will be more manageable for us. So let's start with a new part. We create a part. We have a new part. We insert geometrical set. We call it translation. And now we have to bring our models. So we have here, I created a model of SBR linear bearing. So let's copy it. But in this case, for purpose for this video, I will paste it as a result. Now we have to strip surfaces from this one. I will make an extract from that. Let's create some point or a second plane with offset from this one, ZY. Let's move it somewhere in space. Let's create a point anywhere on this plane. And we wanted this bearing to be translated here. Say point direction, Y component. Let's extract this one and make a new wall. So this bearing be living on this wall. We have our wall. And now we define the screw point. For that I will make a point in a circle, because here we have a circle, we can check it. The icon of circle beneath the caliper icon that tells us that is a certain circle. This is a line and this is a plane. So let's define a point, circle, not surface, circle, and we have our point. We define now axis system with an origin in our point, not the current, because we want always to be current of this original axis system. And to be similar to this axis system, it is by default. So let's leave it how it is. The x-axis tells us the length of the bearing, and the y-axis tells us the width, and z tells us the length. So I will leave it how it is. Let's check our plane, and we wanted to transfer this bearing here. So I have to build an axis system here on this point, and remember that length was the x-axis, so I select this line, and then we have x on this one. And it will be bad because we want the z-axis inverted, but let's make a translation like it is. So I will name it the SBR20 bearing. Now let's make a translation. To do that, you click on axis to axis system for element SBR20. Reference axis system is this one, and the target is this one. But we want it to be height of the linear bearing should be here in this direction, Z, but reversed. So let's create a line which will be the global Z direction, or just let's define it by, let's define a line direction. It will be X direction globally, and we have our line which tells us the Z direction. So let's double click on our new axis system and make that Z axis with this line. It's by default inverted, so okay. And we can leave it how it is, but I want the y-axis to be also inverted, so I make a point direction, and direction our global z component. So I can select the y-axis direction, and then I will reverse it, so I have it always here. So now for the second axis system, it will be much easier to make. Let's define the point, we assume that we want this bearing from second bearing at 400 millimeters. So I will say point type, it will be on curve from this point. So I select the reference, this point, and I can tell in this direction, this little arrow, red arrow show us direction. We can change it also here, but I want it here. And let's say 400 millimeters. So we'll be living here. I create another axis system with the origin here, or I can just copy and paste this axis system and can change the point of it, so it would be similar to this one but at this point. And now the same action for translated this one here. I select my SBR20 and make axis to axis, and I have my element reference this axis system to this axis system. And now we have a nice translation. It will be very easy manageable to us. So, but you can also make a parameter from this one. For example, instead of typing 300 here, we can make a parameter. For this, we click on formula. We define new parameter of type length. We can select, so I pick up length. I click on the new parameter of type and OK. And I have new parameter of length 1. I can rename it to SBR1 to second. And let's define the parameter here at 350. And now I double click on my point, and here right mouse click, edit formula, and I click simply this parameter and OK. Yes, you cannot type anything here anymore, so it will change it here. So OK, and from here I can say 400 millimeters and so on. 200, let's leave it how it is. And again, point in my line, copy any axis system from these two, paste, double click, origin. We change the origin, axis to axis. It's selected axis to axis. Once again, axis to axis element. My bearing, reference. This axis system to this axis system. And OK. So it's now easy manageable. Or by parameter, you can define another parameter. These two bearings are built on with reference of this point, so they're moving with this one. Okay, let's define now some curve to be living on this plane. So let's make a plane. Let's make it normal to curve. This curve at this point. For example, it can be any curve. Let's define 3 points. Point 1, point second, anywhere here, and third point will be anywhere here. Let's make a spline. Our surface will be built up this spline, and let's extrude this spline. It's in the normal direction by default, but I will give this an Y direction. It's the same, and we have such a wall. Let's define a point at this wall, anywhere here. Let's define a normal to this surface at this point. So I will normal to surface. I select the surface, I select the point, and we have a normal to surface at this point. We can see that it's normal at any point here. Let's make a second line. It will be point direction. Our point will be here, and our direction to this surface. Let's build an axis system for this one at the origin here, and we can see the z-axis should be this line. So we click on z-axis. We select this line, and y-axis should be also reversed, so I will make another line with angle normal to curve. I select this curve, I select the point, and for support I will select this one, and my angle I want to be 90 degrees. So we define an axis system here, should be similar to this one's. So we select the z-axis is this one, y-axis will be this one, and x-axis, this line. Make a transformation, this linear bearing with axis to axis. I select this reference and this target. It will be always living on the surface. It will be perpendicular to it at every point. We can select these lines and this point and insert in a geometrical set, name it 1. And we have our geometry, which is needed to build this axis system. We can just copy it and paste. We have the same here, but we can move our point, so we have a copy of it. Now we can, of course, build the similar axis system to this one. Here we pick up an axis system, origin. So x-axis was here, y-axis was there, and the z-axis here. And we can make a translation again with our, we select SBR 20, and axis to axis we select the reference and target. And we can repeat that process on and on. Of course, if instead of surfaces, we can make that in a body if it's closed surface. If surface is closed, we can check in that in the boundary. We select from our translation the translated. Yeah, when we see the message like this, it has no boundaries, so we can close it. So let's insert a body free. We change the module to part design. We select the close surface method and we close, not this one because we can see it. We have to close this one. We checked it and it's closed. So now it has a thickness and everything. We can check, yes, it's built. For now, I will delete it because we want now to replace, we have to replace that all bearings from SBR to HGH. So let's copy HGH from another part. I will copy it and let's paste as a result. So we have our all transformation from this reference. At first, I will extract this in a new geometrical set, I would say. Let's call it translation second. We have here our translation and translation second. So let's change our module to generative shape design. I will extract the surfaces from it and I will hide it. We can make that on two ways. We can give here a new reference and then replace the references, but I think it will be easier to translate here and then change. I will show you that in a minute. So I have to pick a point, not on surface, on circle, and we have also a circle here. I will build a new axis system, not current, with origin here also, like this one, and I will transform it from here to here. So to do that, again, axis to axis system element is our, I didn't name that, I will name it HGH. Now let's make an axis to axis transformation, reference, and our goal. So I will hide it, and this is our new HGH. I will name it also, or translate it maybe. Translated HGH, and now it's the best part. So we replace SBR, so right click on it, replace SBR with translated HGH, and let's take a look at the result. It's translated. We have our new bearings simply translated and with the same. It is all easily manageable and parametric. Let's say for 50 or 500. And let's replace it back. And we have another concept that assumes that we want to put SPR again. So let's put it back. We are in translated HGH. Right click on it, replace by SBR. And let's take a look. It's translated again. Thank you and see you next time.